Stopping distance of vehicles. In this session, we'll learn what is stopping distance mathematically. When brakes are applied to a moving vehicle, the distance it travels before stopping is called stopping distance. The distance traveled by an object before stopping is called stopping distance. It is an important factor for road safety and depends on initial velocity and braking capacity, which is nothing but deceleration, that is negative acceleration, that is caused by braking. Means when you apply brake, the vehicle comes to stop. We need to obtain an expression for stopping distance in terms of initial velocity and acceleration or deceleration. Dear students, we'll learn what is stopping distance. Stopping distance is a parameter. When a moving vehicle, we apply brakes to a moving vehicle, the vehicle comes to stop after traveling certain distance. That distance is called stopping distance. How to obtain mathematically? We have three equations of motion: final velocity equal to initial velocity and acceleration time. Out of the three relationships, the relationship which I will be using is final velocity square equal to initial velocity plus 2 times AS. A stands for acceleration, minus A stands for deceleration or retardation. So what is this stopping distance? The distance traveled by a vehicle once the brakes are applied. You apply brakes, it travels certain distance, then it comes to stop, means final velocity is 0. Let me write it stopping distance. We write a notation D subscript S, that is called stopping distance. Now take for example, initial velocity is V0, your final velocity. The vehicle is moving at some velocity, that is called initial velocity. Now you apply brakes. When you apply brakes, it travels certain distance, then it comes to stop. Take for example, final velocity. Once it comes to stop, final velocity is 0. Take initial velocity is this. Now, equation of motion I will apply. So that is final velocity square equal to initial velocity square plus 2 times AX. I'll be using this equation. This X is the distance traveled. You apply, it is moving with some velocity, that is called initial velocity. You apply brakes, it travels certain distance, then it stops. The distance traveled is called X. We will replace X with distance traveled. X is equal to ds, that is called stopping distance before it comes to stop. Now let me replace it. Final velocity is 0. 0 equal to initial velocity square plus 2 times A. This X is replaced with D subscript S. Then rearrangement gives me minus V0 square is equal to 2 times A ds. I am interested in stopping distance. So stopping distance, that is equivalent to minus V0 square in the denominator 2A. So let me put it a bracket. So this is going to my equation 2. When you look at this relationship, the stopping distance is directly proportional to square of initial velocity. That is, stopping distance is directly proportional to square of initial velocity. Whereas A stands for, if it is positive, it is called acceleration. If it is minus A, it is called deceleration. So ds stands for stopping distance, which is equivalent to negative. Distance is always positive. Mathematically, it looks like V0 square upon 2A. Minus indicates you apply a brake, it loses velocity, means it has some velocity initially. You apply brake, its velocity starts decreasing, it comes to stop. That is why final velocity I have taken 0. If I take typical velocity, initial velocity and stopping distance, if initial velocity is like 11 meter per second, what is the stopping distance? And typically if I take to A equal to 12, some value, if I put into mathematics, my ds equal to 11 whole square In the denominator, this is 2a is replaced with 12. So it becomes 121 divided by 12. Typically, I will get 10. So my stopping distance will be 10 meter. This is measured in meter per second. Similarly, if I measure certain other values, I will be getting 10 meter. So similarly, I will go for some other velocity, typical velocities. Let me cross check for the 15 meter per second. When I substitute 15 meter per second, if I take distance ds is equal to 15 a square, in the denominator 12, it becomes 225. 225 by 12, you can have a mathematics. Distance, stopping distance comes at 12 1 ja, something like 12 8 ja, 108, something like 12 9 ja, 108. Some finally it becomes 1 10 point or something like we'll get 8. So 18 point, let me put 18 point, you'll get some 5 or something like 3. So I'll take it as 18 meter. So what I mean to say, when it is 15, you can take it as 18. Sorry, not 18, it is 19. So 12 9 ja 108, it is called as 19 meter. So I can take it as 19 meter distance. So similarly, I'll get 19 or 20 meter. If you go for the 20, you may get roughly 34. If you go for 25, you'll get 50 meter. This is stopping distance. What we noted here, stopping distance is directly proportional to initial velocity square, provided this a, 2a is a constant. This a minus a is deceleration. I hope you got it. When you go for 11, velocity, initial velocity becomes final velocity 0. 15 initial velocity becomes final velocity 0. 20 becomes 0. You are going to get stopping distance, means as increase in velocity, your stopping distance increases. That's why mathematically it is written as here. ds is directly v naught square. This is the mathematical relation. ds is directly proportional to square of initial velocity. So dear students, two parallel rail tracks run north-south. Train A moves north with a speed of 54 km per hour. Train B moves south with a speed of 90 km per hour. What is the velocity of B with respect to A? There are three sub-questions. I need to calculate relative velocity of B with respect to A, first one. Then relative velocity of ground with respect to B, second one. The third one, velocity of a monkey, I need to calculate. What is the velocity of a monkey? Which is running on the roof of a train A against its motion with a relative velocity of 18 km per second. Yes, with respect to a man standing on the ground. I will repeat. Velocity of a monkey running on the roof of a train. I need to calculate velocity of a monkey. And the train is on the A train against its motion with a velocity of 18 km per hour with respect to a train A, as observed by a man standing on the ground. The numerical under discussion is a relative velocity concept. There are two railway tracks. Train A moves towards the north, which is taken as a positive axis. Train B moving on the other parallel track towards south, which is in this direction. And train A is moving in this direction. Velocity of train A is equal to 54 km per hour. If you do the mathematics, we'll do it. Velocity of train B, which is moving opposite, it is moving towards north, we take it as positive x-axis. It is moving towards south, we take it as negative x-axis. It is 90 km per hour. And hence, we will calculate this also. So velocity of B is going to be 90 kilo means plus 3. Hour means 60 into 60. If you simplify this velocity of B, it comes out to be 0, 0 cancels, it becomes minus 2. Hence, you will get 900 divided by 36. Simplification gives you 25. So like to 18 ja, to 450, then again 18 1 ja, 18 2 ja, to 5. It becomes 25 meter per second. And this is minus n because train B is moving in south direction. So this is a calculated part. Train A moving towards north, we take it as calculated. You convert it again, you'll get 50 into 10 raised to plus 3. It's a kilometer. Kilometer means meter. Each hour equal to 60 into 60 minutes. Mathematically, you'll get 540. So 0 goes, it becomes minus 540 divided by 36. You simplify, you'll get 15 meter per second. This is going to be positive. We calculated velocity of A and velocity of B. The train A and train B. Now, A question, what is the relative velocity? Relative velocity of B with respect to A. So it is going to be VB minus VA, which is going to be, VB is minus 25. This minus sign comes here. Velocity of B I have written. Velocity of A is 15 plus 15. The simplification gives you minus 40 meter per second. This is VBA. This is the first part. Now, or relative velocity of A with respect to B. B, it is velocity of B with respect to A, velocity of A with respect to B, which is equal to plus 40 meter per second. Opposite to this. The B question is, what is the velocity of ground with respect to B train? You have a B train, a person standing on the ground. The person is here, who is standing on the ground, and he watches both the trains. Train A is moving towards north, train B is towards south, and he watches train B. What is the relative velocity of a B with ground? So I can take ground means 0 minus B. Velocity of a ground is rest, 0 minus 25. So it becomes 25 meter per second. This is V ground, you can say VB. The third question is, what is the velocity of a monkey? I need to calculate velocity of a monkey. So what happens? Monkey is sitting on a train A and train is moving towards north. Monkey is moving towards south. Listen carefully. There are two trains. Train A is moving towards north. Train B is moving towards south. Train A towards north. Train B towards south. North, south. North is taken positive, south is negative. A completed, B completed. What is a C means? Monkey is on the roof of a train and the monkey celebrates in the opposite direction of train. If train is moving towards north, monkey is moving towards south. Calculate the velocity of a monkey. But relative velocity of monkey with respect to train A, what is VMA? Velocity of monkey with respect to train A is equal to 18 kilometer per hour. But since train A is moving towards north, monkey is moving towards south, I may take it as minus 18. When you simplify this minus 18 kilometer per hour, because this is positive train, this is the monkey is moving in the opposite direction, I can write minus 18. So you simplify like this, multiply like 18 into plus 3 divided by 60 into 60. So simplification gives you minus 5 meter per second. This is relative velocity of a monkey with respect to train A. I will write it. VMA is equal to minus 5 meter per second. Yes, I hope you got it. The third part of the question is relative velocity of a monkey with respect to train A is given, that is 18 kilometer per hour. I mean to say train A is moving towards north plus velocity. Train monkey is moving on the roof, it is towards south. Since monkey's velocity is not given, relative velocity of a monkey with respect to train A, it is called relative velocity of a monkey with respect to train A is 18 kilometer per hour. I am taking minus because train is moving in north, monkey is moving towards south, means opposite direction, hence minus 18. The simplification gives me relative velocity of a monkey with respect to A in terms of meter per second is minus 5 meter per second. Look at this formula. What is this formula? Okay, see, let me continue here. Relative velocity of a monkey with respect to A can be written as Vm, velocity of a monkey, minus velocity of a train A. Yes, we already know this. This is minus 5u. Yes, velocity of a monkey, I'll keep it as it is. Minus velocity of train A is plus 15. So since this is minus, it comes on this side. It is minus 5 plus 15 is equal to velocity of a monkey. So both gives me 10 meter per second. So this is going to be Vm. So velocity of a monkey is 10 meter per second. I repeat. So Vma is mathematically written as, yes, relative velocity of a monkey with respect to train A equal to Vm minus Va. Already they have given this data. This data is 18 km per hour. 18 km per hour, since train A is moving north, monkey is moving towards south, I need to take minus. Simplification gives me minus 5 meter per second. This is minus 5. Velocity of a monkey, I am interested. Velocity of a train A already calculated. Here it comes out to be 15 meter per second. I just substituted minus 15. It comes this side, it becomes plus 15 minus 5 plus 15 becomes 10 meter per second. Hence the answer is 10 meter per second.